Dear students, I am Nilanjana Sanyal, an online math tutor from India. I tutor students of the IB and the IGCSE boards from grades 9 to 12. This is my website www.nsonlinemathtutoring.com. You may visit my website to know about my tutoring services in more detail. Okay. Now today's video has a title of Infinite Geometric Series Part 4. And the first question of this session says, find the sum of the series up to n terms. Definitely this is not an infinite series. And I'm showing you that this is not a geometric series either. Let me show you that there is no common ratio between the numbers. So the second term of the series is 0.77 divided by the first term 0.7. It is 1.1. The ratio is 1.1 between the first and the second terms. What will be the ratio for the second and the third terms? 0.777 divided by 0.77. See, it is not the same as 1.1. Even if we round it up, we will not be getting 1.1 as the answer, and it doesn't stop over, it is 1.00909, but it is not stopping at this 9. Let me show you. If I take the answer and plus 0. So, you see, this is the number. It is continuing 1.009, then 09, then 0909. It is continuing plus 0. Again, it has given the up to 5 decimal places. Okay. So, this proves that this is not a geometric sequence or series because there is no common ratio. And it is not an infinite series as well. So, you may ask me, why did I take this question in this session? Because this can be converted to a geometric series. But definitely it will not be an infinite geometric series. It will be a finite geometric series up to n terms. But in this session, we will be having two typical questions. I wanted to keep them together. Therefore, I have taken this question under the heading Infinite Geometric Series, Part 4. Okay, in this session, you will be seeing two typical questions solved and explained, which I wanted to share with you. Okay, so let us start with our first question, which says find the sum of the series up to n terms. The first term is 0.7 plus the second term is 0.77 plus 0.777 plus 0.7777 and so on. Up to n terms. And I have shown you this is not a geometric sequence or a geometric series. Then how do we get the summation of the first n terms of the series? I am showing you. So let's start with our answer. Okay, and another thing that I have to apologize is my previous video is having some audio volume problem. I have seen that after I have published the video. I did not realize before, so I'm extremely sorry about that. I hope that this video will not be giving you any audio problem. So, please do watch this video till the end. You will be enjoying watching these two typical problems solved and explained. Okay. So 0.7, let me just take this 7 out. And I will be having 0.1 plus 0.11 plus 0.111 plus 0.1111 and so on. Okay. Even this is not a geometric sequence. Let me show you. 0.11 divided by 0.1. It is 1.1. But 0.111 divided by 0.11, it is not equal to 1.1. Okay, you see it is the same value that we had before. Okay. So, now we are having the, let me not put the equal to sign because it is the given question that I am modifying, the given series that I am modifying. Okay, I have just taken out 7 from all the terms. Next, what I want to do is, I'll be multiplying all the terms within the parenthesis by 9. For that, I have to divide by 9 as well because I cannot just multiply the terms by 9. That will be changing the value of the series. So, I am dividing by 9 as well. Okay, because 9 divided by 9 is 1. So, I get 0.9 plus 0.99 plus 0.999 plus 0.9999 and so on. This will definitely not be a question from the SL part, IBSL part. It may be a question from the HL part, depending on the school. Okay. So now we are having a sequence, but an infinite sequence within the parenthesis, and even this is not a geometric sequence. So I have to modify that. Now 0.9 can be written as 1 minus 0.1. Okay, and all these are added to up to n terms. Okay, so instead of 0.9, I am writing 1 minus 0.1. Instead of 0.99, I can write 1 minus 0.01. Okay. Similarly, instead of 0.999, I may write 1 minus 0.001 and so on. Okay, up to n terms. So this is equal to 7/9. And how many ones we will be having? It will be, I'm just separating the ones. So 1 plus 1 plus 1 plus, I'll be getting a 1 from every number that I have changed, and I have converted this single number to 2 terms, this one to 2 terms. So every group of 2 terms, from every group of 2 terms, I am getting a single 1. And how many groups are we having? Obviously, there will be n number of groups because there are n terms. So, you will be having n number of ones. Okay, I am not writing, okay, let me write n terms. N number of ones I am having. And then minus 0.1 plus 0.01 plus 0.001 plus, again you will be having n terms, but this one, this is n terms again, but this one, you see, this is a geometric series with the first term as 0.1. And what is the common ratio? Let me show you what is the common ratio. It is 0.01 divided by 0.1. It is 0.1. See the next two terms, 0.01 and 0.001. So we take 0.001 divided by 0.01. Again, you see, you get the same common ratio. Same ratio. So now it has got converted to a geometric series with the first term as 0.1 and the common ratio as 0.1. Okay? But it is not an infinite series. It is up to n terms. But we know the formula for both infinite geometric series and finite geometric series, so we should not have any problem. Therefore, this will be equal to 7/9, and this is n number of ones. So, this will be equal to n. 1 times n is n minus, what about that part? Let me just write it over here. Sn is equal to u1, the first term, and it may be, let me take this one formula because r is less than 1. So I am taking this formula. Okay. So this is the formula for the summation of the first n terms of a geometric series, with the first term as u1 and common ratio as r. Okay. So we will be applying this, and the first term in this case is equal to 0.1. So it is 0.1 bracket 1 minus r is equal to 0.1 to the power of n divided by, I can take this as well, and 1 minus the r is 0.1. Okay. So this is equal to 7/9 times n minus 7/9, and this one is 0.1, and 1 minus 0.1 is 0.9. Okay, and you are having this part 1 minus 0.1 to the power of n. And if I multiply this by 10 and this by 10, I get Sn to be equal to 7/9n minus 0.1 times 10 is 1 and 0.9 times 10 is 9. So it is 7/81 and 1 minus 0.1 to the power of n. So this is our answer. This whole thing is our answer. So you see, even though the initial series that has been given to us is not a geometric series, we have converted that series to, at least a part of that series, to a geometric series, and we have used the formula of a finite geometric series to come to the answer. Okay, so this will be our answer for the first question of this session. Let us move on to the second question. show that 1 over 4 plus 2 over 8, which is also equal to 1 over 4. Okay, since they have given it in the form of 2 over 8, let us keep it as 2 over 8 plus 3 over 16 plus 4 over 32 plus, very sorry, this should be equal to 5 over 64 and not 34. Okay, it will be 5 over 64 plus dot dot dot. This is an infinite series and we have to show that the sum total of all the infinite terms is equal to 1. Okay. I'm extremely sorry about this. This should be 5 over 64. So let's start with our answer. So let us write S is equal to 1 over 4 plus 2 over 8 plus 3 over 16 plus 4 over 32 plus 5 over 64 plus dot dot dot. And again, let me show you that this is not a geometric series at all, because 2 over 8 is equal to 1 over 4 and 1 over 4 divided by 1 over 4 will be giving us a 1 as the ratio. So the ratio between the first and the second terms is equal to 1. So what is the ratio between the second and the third terms? 3 over 16 divided by 1 over 4. So it is 3 divided by 16. This is getting divided by 1 divided by 4. Okay. This is equal to 0.75, which is not equal to 1. From the first and the second terms, we have found the ratio to be equal to 1. But from the second and the third terms, the ratio is 0.75. Therefore, this is not a geometric series. Okay, that is why I have kept these two questions in a single video, because this is the one property that they are having in common, that the series given are not a geometric series, but they can be converted to a geometric series, or part of it can be converted to a geometric series. Okay, so next thing that we want to do, or we will be doing, is we will be dividing the entire equation by 2. So it is S over 2. 1 over 4 divided by 2 is equal to 1 over 8. Plus 2 over 8 divided by 2 is equal to 2 over 16. Okay, so we are dividing each term by 2. 1 over 4 divided by 2 gives us 1 over 8. 2 over 8 divided by 2 is 2 over 16. 3 over 16 divided by 2 is 3 over 32. 4 over 32 divided by 2 is 4 over 64. 5 over 64 divided by 2 is 5 over 128, and so on. It is an infinite series. Next, I'll be subtracting them. Okay. So, of course, the signs will be getting changed. So, this is this, this is this, this is this, this and this. Okay. And on the left hand side, we are having S minus S divided by 2 is equal to, now 1 over 4 we write it as it is, and we are having, see, 2 over 8 we are having from here, and this is minus 1 over 8. So 2 over 8 minus 1 over 8 is equal to plus 1 over 8. Next, 3 over 16 and 2 over 16. 3 over 16 minus 2 over 16 is 1 over 16. 4 over 32, 3 over 32, 1 over 32. Similarly, 5 over 64, 4 over 64, 1 over 64. And it continues. Now you see, this is an infinite geometric series with the first term as 1 over 4 and the common ratio as half. 1 over 4 times half is 1 over 8. 1 over 8 times half is 1 over 16. So this is an infinite geometric series, a convergent infinite geometric series with the first term as 1 over 4 and the common ratio as half. So half is less than positive 1 but is greater than negative 1 and is not equal to 0. Hence we can apply the S infinity formula for this infinite geometric series. Okay. And S minus S over 2 is equal to S over 2. Now this is equal to, let me write over here, what is the formula for infinite geometric series, convergent geometric series? It is S infinity equal to U1, the first term, over 1 minus R. R is the common ratio. So this is the formula which I'll be using. The first term is 1 over 4 divided by 1 minus R is half. So this is equal to 1 over 4, 1 minus half is half, divided by half, which is equal to 1 over 4 times 2 over 1, which is equal to half. Okay. So S over 2 is equal to half. Therefore, S is equal to 2 times half, which is equal to 1. Okay. So we have shown that the sum of the infinite number of terms that they have given is indeed equal to 1. Okay. I cannot fit the two parts together, but you can see that S equal to 1. This is shown. Okay. This is shown. So we have proved, we have shown this one, and we have found the sum total of the first n terms of the numbers given in our first question. Now it is the time for getting some homework questions. This brings us to the end of this topic, infinite, both finite and infinite geometric series. Our next video will be on the topic sigma notation. We will be starting with the new topic sigma notation. Okay. So it is time for having some homework questions. There will be 2 homework questions. The first homework question says, find the sum of the following series. So it is a finite series because they have given up to 15 terms. And they did not mention what type of a series it is, but I am seeing that you are having a common ratio. I am not saying what is the common ratio. It is up to you to find out what is the common ratio, and I am sure that you will be able to find out. The first term is 0.1, and what is the common ratio? It will be the sum total of the first 15 terms of a finite geometric series. You will be seeing that there is the common ratio. It will be a negative number. That is a hint. Okay. And question 2 says, show that a geometric sequence with the first term as 3 and the 7th term as 1 over 243 has 2 possible sums to infinity. So, first of all, you have to show that this is a case of a convergent infinite geometric series, because they are saying two possible sums to infinity. That means that this geometric series, the infinite geometric series, is a convergent one, and you will be having two possible sums and you have to find those sums. Okay. So these are the two homework questions for you. And this brings us to the end of this session. We'll be meeting again in our next video very soon. So students, thank you for watching this video till the end. Thank you for staying with me till the end. Please give this video a like if you found it useful. Please subscribe to my YouTube channel. It will be motivating me to make more math videos so that you may be getting some help in your math classes. Okay? And do not forget to press the bell icon. You'll be getting notified as soon as I publish a new video. So bye for now.